In this video, we're going to talk about the angle measurement, specifically angles that are measured or formed in the Cartesian plane or the rectangular plane. Okay, so angles are formed when two rays, we call them the initial side and the terminal side, are drawn with a common vertex. Okay, so it looks something like this one. So we have here the vertex, the initial side, and the terminal side. All right. And so an angle is formed as the amount or measured as the amount of rotation from the initial side to the terminal side. Okay, so it's either a counterclockwise rotation from the initial side to the terminal side or a clockwise rotation from the initial side to the terminal side. Okay, now let's say the vertex is situated at the origin of the Cartesian plane. So we have here positive y-axis, negative y-axis, and then the negative x-axis and the positive x-axis. Now, the angle formed here has a vertex situated at the origin, and its initial side, if its initial side is fixed at the positive side of the x-axis, then the angle formed here or here is in its standard position. Okay, so again, an angle in its standard position is in its standard position when its vertex is situated at the origin, like this one, and its initial side coincides with the positive x-axis. So here, okay? So the angle, again, the angle formed here is in its standard position. Now, I mentioned about the counterclockwise rotation and the clockwise rotation, right? This is important because it affects how the angle is measured, all right? So it depends on two things. Number one is the direction and the amount of rotation. Okay, the direction will tell us the sign, either it's a positive angle or a negative angle. Okay, and then the amount of rotation, of course, will tell us how many degrees or how many radians is the angle. Okay, so again, don't forget that the measurement is from the initial side, which is the fixed or the stationary side, to the terminal side. This is the moving side. So let's look at this one, this angle here. This is an angle in its standard position, right? Its vertex is at the origin and its initial side is fixed at the positive x-axis. Okay? So this is a counterclockwise rotation. If the rotation is counterclockwise, then the angle is positive. Alright? If the rotation is clockwise, then the angle is negative. Now let's talk about how angles are measured in terms of the units. Okay, so we have two main units used in measuring angles. We have the degree unit, and number two, we have the radian unit. Okay, so first, let's talk about degrees. When the initial side, which is fixed in the positive x-axis, is rotated once counterclockwise or clockwise until the terminal side reaches the initial side or the initial position, it covers a total measure of 360 degrees or one revolution, right? So for example, if we have here the vertex of a standard angle or an angle in its standard position. So we have here the vertex at the origin, y-axis, x-axis. The initial side, if we make one full revolution, then the total measure is 360 degrees. Therefore, 1 degree is measured to be 1 over 360 of a revolution. Now let's talk about radians. Okay, this is the SI unit of the angle measurement. Alright, so a radian is the angle measurement of the central angle of a circle if the radius of the circle is equal to the length of the arc subtended by the central angle. So for instance, let's say we have a circle whose radius is 1 unit, say 1 centimeter or 1 inch or 1 foot or 1 meter. Okay, so all those are representations of 1 unit. Okay, the measure of this central angle here is said to be 1 radian if the length of the subtended arc here is equal to the radius of the circle. So in this case, 1 unit. All right. Similarly, for instance, if we have a bigger circle, like this one, for instance, this is, or the radius is measured to be 3 units. Okay. The central angle here is measured to be 1 radian again if the subtended arc or the length of the subtended arc here is equal to the radius of the circle, which is in this case 3 units. All right. So again, if uh, the length of the subtended arc is equal to the radius of the circle, then the central angle or the subtended angle is measured to be 1 radian. Okay. Now remember I mentioned earlier that radians is the SI unit of measuring angles. Okay. In calculations, we always work with radians because it allows us to relate angle measurements with linear measurements. All right, linear measurements like measurements of lengths, distances, where the units are in centimeters or inches or feet or meters, kilometers, so on and so forth. In other words, uh, the radian unit brings or keeps the angle measurement on the same scale as the linear measurements. Okay. And with that, we need to know the conversion from degrees to radians and vice versa. All right. So to convert from degrees to radians or radians to degrees, first we need to recall the relationship between the central angle, the subtended arc, and the radius of a circle. So the relationship is defined by this equation. S equals r theta, where S is the subtended arc, the length of the subtended arc, r is the radius of the circle, and theta is the central angle. Now, for one revolution, theta is equal to 360 degrees, right? And S, or the subtended arc, the length of the subtended arc, is equal to the circumference of the circle itself, where the circumference of the circle is defined as 2 pi times the radius. Okay, and so if we plug in the value of theta and the equivalent expression for the subtended arc, then this equation becomes 2 pi r equals r theta, where theta is 360 degrees. Okay, and since we are talking about the same circle, the radius is equal. All right, so we can cancel out the radius. Therefore, we are left with 2 pi equals 360 degrees. This equation means for the basis of one revolution, 360 degrees is equal to 2 pi radians. We can now use this equation to convert degree unit to radian unit and vice versa. Okay, we can also simplify this as pi equals 180 degrees. Okay, and so from this equation, the conversion factor or the conversion factors are, first we have 1 degree is equal to pi over 180 radians, or 1 radian is equal to 180 over pi degrees. Okay. So for instance, if we want to convert 60 degrees to radians, then we use the first conversion factor. Okay, so pi over 180. This is 180 degrees, right? So dimensional analysis, the degree unit will cancel out, the radian unit will remain. That is why the resulting unit is radians. Okay, and so this is equal to pi over 3 radians. All right. Conversely, if we want to, for instance, convert pi over 6 radians to degrees, then we use the second conversion factor. All right. So pi over 6 radians, we have here 180 degrees over pi radians. All right. So pi cancels out. So we have 180 degrees divided by 6. We get 30 degrees. Okay. This means that pi over 6 radians is equivalent to 30 degrees.